Okay, this is Unit 1 review question number 4. Determine what constant should be added to create a perfect square trinomial. Well, in order to create a perfect square trinomial, we have to complete the square. Okay, in order to do that, I have to take a half of my b term. And my b term in this case is a value in front of the x. Okay, so it's -7. So 1/2 times -7 equals -7 halves. Okay, and then I have to square that value. So complete the square, right? So I'm going to square both sides. So what this does is I get 49, which is 7 squared, over 2 squared, which is 4. And a negative times a negative makes a positive, and that's how I got a positive 49 fourths. So in order to write what comes next, we're going to write 49 over 4. That will create the perfect square trinomial. So if I write the trinomial, I get x squared minus 7x plus 49 over 4. Now, that factors out into two binomials that are completely the same. And to find out what those values are, we just have to look at what happened before we squared the b term. So do you see the -7 halves? That is what goes there. Okay, so this can be written as x minus 7 halves quantity squared, and that allows me to complete the square. Okay, and to factor the trinomial, I just did that. So in that splot, or in that splot, I don't even think that's a word, but in that spot is x minus 7 halves quantity squared. Okay, let's move on to number 5. Solve by completing the square. Okay, so when you complete the square, there's a couple rules that have to be in place. 1, the value in front of x squared has to be positive and has to be 1, which in this case it is, so I don't have to do anything there. And 2, I have to move the constant over to the other side of the equation. And I'm adding spots because when I complete the square, I will get a perfect square trinomial on the left-hand side. And whatever value that is that allows me to make that, I have to add it to the right-hand side as well. So that's why the spots are there. So again, if I want to complete the square, I got to take 1/2 of my b term. So 1/2 of -6 is -6 halves, which is -3. Okay, so I'm going to take -3 and I'm going to square it, which gives me a positive 9. So I'm going to add 9 to both sides. Okay, on my left-hand side, when I factor this out, it becomes x minus 3 and x minus 3. And just like the last one, before you square the term gives you a hint of what goes in these binomials. Now on the right-hand side, I have 9 minus 4, which is 5. Okay, so I can write this up as x minus 3 quantity square equals 5. To get rid of something squared, I have to square root it. So I'm going to square root this side. So square root of x minus 3 quantity squared equals the square root of 5. So now I have x minus 3 because square rooting something squared gets rid of it. And I have on the other side plus or minus radical 5. Again, anytime you use the square root, you have to put plus or minus. Okay, so my answer is going to be x equals, I'm going to move the 3 on the other side, so 3 plus or minus the square root of 5. So I get two answers, 3 plus square root of 5 and 3 minus the square root of 5. Okay, that's number 5. All right, let's look at number 6. Solve using the quadratic formula. The quadratic formula is -b plus or minus b squared, the square root of b squared minus 4ac all over 2a. Okay, that's quadratic, and that's what x equals. Okay, so before I start this out, I need to move all my terms onto the left-hand side. So I'm going to move the x over so I get -x. I'm going to move the 1 over so I get -1. Once they're on the left-hand side, I can read off the values. A equals 1, B equals -1, and C equals -1. Now I'm simply going to plug in those values into the quadratic formula. Okay, negative b. So negative -1 plus or minus the square root of, now I have b squared, which is -1 squared minus 4 times a, which is 1, times c, which is -1, all over 2 times a, which is 1. Okay, now to simplify. X equals 1 plus or minus the square root of 1. Now 4 times 1 is 4. 4 times -1 is -4, and then I have a negative hanging out, so I get +4 all over 2. Okay, we're getting there. So x equals 1 plus or minus the square root of 5 over 2. So I have one answer that's 1 plus the square root of 5 over 2, and another answer that's 1 minus the square root of 5 over 2. By the way, this is called phi. It is used for the golden ratio in art, architecture, and in plastic surgery sometimes. It's seen as the perfect ratio by the ancient Greeks for creation of things that are symmetrical and aesthetically pleasing to the eye. So I just wanted to throw that out there. Okay. All right, guys. That is, what did I do? 3 through 6 here. Oh yeah, 4 through 6. So thank you for watching, and I'm going to make videos for the rest of them.